Today's lesson is over exponential functions, and this is what an exponential function looks like. Your b value is the base of the function. So let's look at our first example. Our base here is a 2. We're going to fill out a table, and we're always going to start with these simple values. For my first x value, I'm going to plug in a -2. Whenever you have a negative exponent, you are going to flip this number. So instead of 2, it will be 1/2. Whenever you flip this number, this exponent is now positive. So what is this equal to? 1/4. Because 1 squared is 1, 2 squared is 4. Now let's plug in the next x value. When you have a negative exponent, that flips this number. So this will become 1/2 to a positive 1. And so this becomes 1/2. And I like to write these as decimals. So how would you write 1/4 as a decimal? 0.25. Yep, 0.25, and this one is 0.5. Do you guys remember what anything to the power of 0 is equal to?
Just itself?
Nope.
1.
1, it's equal to 1. 2 to the power of 1 is itself. Anything to the power of 1 is just itself. And then, of course, 2 squared is 4. So this is my parent table. Okay, I'm going to graph my points. So -2 with 0.25 is really small. It's down here. -1 and 0.5, right there in the middle. 0, 1, that's my y-intercept. 1, 2 is right here. And 2, 4 is right there. Also, if you wanted to continue, what's 2 to the power of 3? 8. So we can graph that point as well. And if I were to plug in a -3, what do you think that would be? 1/8. And that's really small. So notice your fractions just get smaller and smaller. Will it ever get to 0? No, it will never get to 0. So if you graph this, this is what our graph will look like. It will get very close to 0, but if you continue this table, it is not actually going to equal 0. That is called an asymptote. So everyone go ahead and sketch the asymptote. It's right here at the value y equals 0. That is the line you will get very close to but never touch. This is our next function. We're going to create a table. We're always going to plug in these x values, -2 to +2. So if I have 1/2 and I plug in a -2, remember, you flip this number so it becomes 2/1, and this exponent is now positive. So evaluate that. What would it be? 4. Next one, you have 1/2 to the power of -1. If it's a negative exponent, you must do the reciprocal. You flip it. Now it's a positive 1. What is this? Evaluate that.
2.
Anything to the power of 0?
1.
Power of 1? 1/2 to the power of 1?
Oh, 1/2.
It's just 1/2. It's always itself. And then 1/2 to the power of 2? 1/4. Because 1 squared is 1 and 2 squared is the 4. All right, so that is your next one that you need to write down, and we're going to graph it. So -2, 4, that's up here. -1, 2, 0, 1, 1.5, and then 2 1/4. So this one is decreasing. You will have exponential growth whenever your base is greater than 1. So notice for the graph 2 to the power of x, your base is 2, that's greater than 1. You have exponential growth. It is increasing. You will have exponential decay when your b value is between 0 and 1. It will decay, it will decrease. Now, a lot of people say, oh, well, whenever it's a fraction, that means it's going to be decay. But that's not always the case. Because what if I had 9 over 2? 9 halves. 9 over 2 is the same thing as 4.5. So 9 halves is actually bigger than 1. So even though that's a fraction, this is not decay. That would be growth. I'm going to put this table on the board, check your paper, and see if it's right. You always start with these numbers. So 10 to the negative 2. You flip it, so it's 1 over 10 to the power of 2. 1 squared is 1. 10 squared is 100. This can also be written as 0.01 So that's the decimal form. This will become 1 over 10, which is also 0.1. Anything to the power of 0 is just 1. 10 to the power of 1 is just 10. And 10 to the power of 2 is 100. So these are your values. And then 110 is way up here. So this is your graph. Where is your asymptote? This is the line you'll never get to, but get close to.
Why don't we just call it the y-axis?
It's the x-axis.
X-axis.
But we call the asymptote y equals 0. That's the asymptote. So this is the line that you get very close to, but do not touch. So notice this fraction is getting really small. If you went to negative 3, it'd be 1 over 1,000, which is very small. That would be 0.001. So your numbers get very, very tiny. They stay above 0. Make sense, guys? Okay. So your domain, you're going to go forever to the right, and you're going to continue forever to the left. So this is all real numbers. You can also write it as negative infinity to infinity. Your range. The very bottom is at 0, but it never equals 0. So I'm going to put a parenthesis and not a bracket. It gets close to 0, but it doesn't touch it. That's why it's a parenthesis. It doesn't equal it. Yes?
Why don't you just put the 0.01 there?
0.01? That's not the smallest it can be. If I plug in a negative 3, it'll be 0.001. If I plug in a negative 4, it'd be 0.0001. So it's going to get smaller and smaller and smaller. Okay, very good question. Now, our end behavior. As x goes to infinity, your graph is going up. So this is infinity. As x goes to negative infinity, so as you go this way to the negative side, your graph is getting closer and closer to this asymptote, which is at 0. So those are your end behaviors. Your y-intercept is right here at 0, 1. Okay, any questions on how we answered these questions? Good. Okay, I want you guys to try this one.
Teacher, I have a question.
Yes?
Is the asymptote always going to be y equals 0?
Oh, that's a good question. Okay, so if I transform this and put like a -4, that means everything goes down 4. So now your asymptote is here at -4, and this would be your new graph. So no, not always at 0. Okay, so now let's talk about transformations of exponential functions. What did you guys put for this first blank? H is the, what kind of shift? Yes, horizontal. So this letter right here, the H, in there with X, it does a horizontal shift left and right. So if you have a plus sign in there, which way will it go?
Right. Oh, left.
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 Right.
It's always the opposite. Shh. It's always the opposite in the parentheses, okay? What about if you have a minus sign?
Right.
There we go. Okay, now the K value that's over here in the back, what kind of shift is that?
Vertical.
Yes, the vertical shift. If you have a plus sign, which way is it going?
Up.
Up. It's not opposite here. It's only opposite in the parentheses. And then if you have a minus, it is down. Okay, if A is negative, so if you have a negative in the front, the function is what?
Reflected.
Yes, reflected. Across which axis?
X.
X-axis. Okay, if the absolute value of A, so we're not talking about this negative, we don't care if there's a negative in front, you're just looking at the A value. If it's greater than 1, it's a vertical
Stretch.
Good, y'all remember.
Mm-hmm.
And if it's between 0 and 1, it's a vertical
Compress.
Yes. Okay, I want you guys to write this down. Horizontal shifts, that affects the X value because your X-axis is horizontal. A vertical shift, that is going to affect the Y values because your Y-axis is vertical. That affects your Y values. Reflections, that affects the Y value. A vertical stretch, vertical compress, the key word is vertical. Anything that's vertical, that affects the Y value because your Y-axis is vertical. Now let me prove to you that a reflection only affects the Y value. So here's an example. This is the point 1, 3. If you were to reflect it across the X-axis, it would be right here. It would flip across the X-axis. Now what is this point?
1, -3.
Yep. Do you guys see that only the Y value changed and the X value stayed the same? So guys, the only transformation that affects the X value are horizontal shifts. Everything else will affect the Y value, okay? All right, so we're going to go ahead and do a transformation. First, we're going to talk about the parent function. The parent function was 2 to the power of X. And then they moved the parent function left 3 and down 1. So the table for the parent function, you always start with these values. And if you look back at your notes, the Y values, it was 0.25, 0.5, 1, 2, and 4. Okay, this was the table for 2 to the power of X. However, these points were shifted left 3 and down 1. The left 3 means I'm going to subtract 3 from all of the X values. Down 1, that affects the Y values. You're going to subtract 1 from all of these Y values. So now, let's find our new points after it was transformed. -2 minus 3, that's -5. -1 minus 3, -4. -3, -2, -1. These are my new X values. They were all shifted to the left 3. Now my Y values, these were moved down 1. So 0.25 minus 1 is -0.75. 0.5 minus 1 is -0.5. 1 minus 1 is 0. 2 minus 1 is 1. 4 minus 1 is 3. So this is my new graph. This is the original graph. This is the new graph after it was transformed. So I'm going to plot this graph here. So -5, -0.75, -4, -0.5, -3, 0, -2, 1, -1, 3. This is your new graph. Do you guys know where the asymptote is?
-1.
Good. And it always tells you in the equation right here. If it moves up or down, that's your asymptote. So your asymptote is at y equals -1. Your domain is always going to be all real numbers. You can write it either way. Your range, everything is above -1. So you can say y is greater than -1, or you could say -1 to infinity. However you want to write it. End behavior. As your x values move to the right, what's happening to your graph?
Goes up.
And then what about when you go this way?
-1.
-1 to the asymptote. Now, y-intercept. In the past, how did we find the y-intercept?
Plug in zeros for x's.
Exactly. You plug in zeros. Okay, so in this case, if I plugged in a 0 here, what's 2 to the power of 3?
8.
Minus 1?
7.
So your y-intercept is 0, 7. So let me add that to my graph. 0, 7. What is the original function? Thank you, Charles. 4 to the power of x. Then they did a reflection, a stretch, right 2, down 3. But this is the original function, okay? So before we get started, can you guys make me a table for the original function? Go ahead and fill this out, please. Okay, now remember, this went right 2. So for the x column, we're going to add 2 to all of these. Everything else affects the y. Now look closely. This is being multiplied by a negative 2, and then you're going to subtract 3 because it went down 3. So you have to do order of operations. Multiplication comes first. So you're going to multiply everything by negative 2, and then you're going to subtract 3. Okay, so I'll help you guys out. X's are easy. Let's do this one. 1 over 16, put that in your calculator. It'll give you a decimal. When you have the decimal, call it out, please. 0.0625. That's 1/16. Now multiply this by a negative 2. Hit times and then negative 2. Multiply it. Negative 0.125, you said? Okay, thank you. And then subtract 3. Let me know what you get. Negative 3.125, thank you. And the x value, negative 2 plus 2, that's 0. Okay? Negative 1 plus 2 is 1. 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2, we get 4. Okay, now these values. 1/4 times negative 2, that's negative 0.5. Minus 3, this is negative 3.5. This is negative 2 minus 3, that's negative 5. Negative 8 minus 3, negative 11. Negative 32 minus 3 is negative 35. So this is your new table. I'll go ahead and graph it. 0, negative 3.25 is about right here, a little bit past negative 3. Positive 1, negative 3.5 is right there. 2 and negative 5 is right here. 3 and negative 11 is right here. And then it just keeps going down. So this is your graph. Your asymptote, it went down 3. So your asymptote is right here at negative 3. Your y-intercept is this value, 0, negative 3.125. As x goes to the right, what is your graph doing?
It goes negative.
Yep, it goes down to negative infinity. And as it goes to the left?
Negative 3.
Yep, negative 3, the asymptote. Your range, your very bottom is at negative infinity, and the top is at negative 3. You could also say everything is below negative 3. And your domain is always all real numbers. Let's look at this problem. The parent function is 4/3 to the power of x. So this parent function was reflected over the x-axis. It moved to the left 2, and it was shifted up 7. The parent function here is 5 to the power of x. And the transformations, it was vertically stretched by a half. It went right 4 and down 2. So I do not want you to confuse this as some type of vertical stretch. This is your base. Your base is greater than 1, so this is going to be a growth. Your graph will look like that, exponential growth. For this previous problem, your base is greater than 1, so this is also an exponential growth.